Hi everyone, hope you all are keeping well. Speaker for today's Tech Talk session is Didula Dissanayake. He will be speaking on React Tensor. So over to Didula.
Thank you. I'm going to start the presentation, but today my Tech Talk is scheduled for regarding the React framework. But today I'm not going to explain about the detail about the React. But today I have focus on the particular subject that is one of the major item in the React is a virtual DOM. So go to the slide. First of all, I'm going to the DOM. What is everybody heard about the browser DOM? So everybody has written the HTML code and can have opened the HTML file in the browser. So that is called browser DOM. How it works? Here actually DOM stands for the document object model, and it is an abstraction of the structured text. And actually it is a structured text, it is the HTML format. And for the web developer, it is HTML code, and DOM is simply called browser DOM. And when it's it means when we write the HTML code, then it's loading through the browser. It keeps the HTML code inside the browser in the memory, but it keep it as a DOM. We call it browser DOM. The HTML element become the nodes in the DOM. So when everybody has some familiar with the jQuery and JavaScript, and so first of all I go to the JavaScript because the jQuery is built based on the JavaScript. JavaScript has provided some API to manipulate our DOM. So let's assume get element by ID and change remove child. These are some APIs to change the value and change some changes in the React. So to the DOM dynamically and view the content update. So this is the common one. So then I'm coming to the virtual DOM. Then some frameworks has been developed, that is the React, Vue and the Ember. Those have a separate DOM called virtual DOM. It's a little bit different. Browser DOM is okay, it is available in the browser, but virtual DOM is generate the separate DOM instead of the browser DOM. But when the React process the application, we need the browser DOM and the virtual DOM both. We'll explain later. Here it is a virtual DOM is an abstraction of the browser DOM. It is lightweight and detached from the browser spec implementation details. Next, it is already abstraction. DOM is already abstraction, but so when it comes to the virtual DOM, it's an abstraction of the abstraction, because these details actually keep in memory as a JavaScript object when it comes to the DOM level. But if you are doing the React application, we don't need to worry about this one because it handles internally. But the concept behind the virtual DOM and the process behind the virtual DOM is very important to understand the some mechanism and to use the best practice in the React or some web application. This is the major fact to come up with the virtual DOM concept. Instead of accessing the browser DOM directly, virtual DOM is actually extremely very fast, and it can produce many DOMs within a short time. That's another advantage. And one of the major features is this one, where it creates the DOM from the scratch, every state change or property change. That's the way. But when it comes to the browsers, it will be different behavior. So next one is how virtual DOM works. Both DOMs, one means browser DOM and the virtual DOM, has a three structured data set and the same. So same because one of the major thing is both are same actually, but little bit differences. Browser DOM's main purpose is to rendering, but virtual DOM's main purpose is to traversing the elements. So that's why browser DOM does rendering to paint the content, the screen, and the virtual does not. It creates the new DOM and pass the particular nodes to the subsequent nodes to the browser DOM to be rendered. For that purpose, to make it work and make it perform, there is a new algorithm called diffing algorithm to make it efficient. This is how I'm going to explain how it works. In this diagram, we have two parts. In the top part is explained about the virtual DOM. Other one is the browser DOM. Here, in the first virtual DOM, one element, let's go to the top left one red color element. It means it has a one update in the state change in the or property change in the particular element. That is called state change. At that moment, browser DOM is nothing. Something doesn't happen. Then it's compute the diff. Diff is the identify the where the in the virtual DOM, identify the where the change is applied, and find the subsequent element, and then comes to the re-rendering part. At the re-rendering part, virtual DOM does nothing. Then it's sent to the message to the browser. Here, hey browser DOM, this is the part, this is the place, and this is the subsequent elements. We have to apply this one and render it. So at that moment, then when you see the bottom part, the bottom right hand one, 3 circles have been colored with the red. It means this particular change is applied and it is browser render the particular part, re-render the only, repaint the particular part only. So that is the way it works. We'll explain in the beginning from the again.
Didula, so basically here, like, let's say if particular element got changed or state got changed, right? So when it actually re-render, it actually re-render the tiles underneath also along with that?
Yes. Yes. Okay, we'll explain
so
it.
Not only, so you're going to explain it later?
Yeah, these are the way I'm going to explain in detail, because here again I want to explain how it works here, but I explain only process. So when it comes to React level, I will explain how it works again. Okay, let's assume when the application is started, something is displayed in the browser. At that moment, browser DOM is generated and the virtual DOM is generated. Okay, so both are same. Both are same means, but it's not exactly same, but has some little bit differences. But almost same is because the calculation. Okay, so then I think I need to change let's assume one of our content has to show when the birthday change, and we need to display what is the age. So at that moment, the state has been changed. The age has been changed. So so at that moment, the React create another DOM. One is available.
Sorry, again. So are you showing the same slide? I think it has to be the next slide. Right?
No, this is I explained about here. I explained about how it works, but actually I want to explain about how it works. So better to I will come to this one. Okay, first React. Okay, when the application is started, browser displays some content. It means it has a browser DOM, and in additionally, browser have virtual React has created another virtual DOM also. So then change some content or property has been changed. Let's assume birthday has been changed at this moment, and we need to display the content. Then how React do is, React also has created the one DOM, and then when the particular update happened, React create another DOM. There's a new DOM. Then identify. Then it's new DOM, new virtual DOM compare with the existing virtual DOM. Existing means existing old one. Here we called it. We take the snapshot of the old one and go through the application. Go through the DOM. What are the differences? Here, the compute defeats that part. State changes when the state something. That is the scenario. When state changes, identify what are the element state has been changed and how it should be affected. So then identify the parent element and identify the particular element node, and it's sent to the browser DOM mentioning this node has been changed. Please update the particular node and the subsequent all the nodes. So when something happens, actually it's 3 DOM has been created available. Change and changing is one is because at each time at the any state change or property change, React create the new DOM.
Okay. So I think So basically, what happens is when there is a property change, right? So React first create, clone kind of thing. Yeah, and then it creates another DOM, another virtual DOM out of what is available there. and then do a diff, right?
Yes.
And
there's a major part is the difference checking with the existing old DOM, existing DOM and the new DOM. When it comes to the JavaScript level, it doesn't do this part. It doesn't particularly. It does call to the browser DOM. Say here, hey, this is the place. Please update this value. But React is a little bit different. It doesn't call to the React browser DOM directly. Okay, got the point. Shall I move to the next one? Or shall I explain it?
No, you can move.
Okay. This is the flow and how I explain it. Okay, same. I will explain it again. Initially, this stage. This is the part. Let's assume this is the nothing is colored. This is the initial part. So then state change, the red color one is updated. Then it's do the compute differences. Compute differences means it happens through the React. It compute the difference call. It take the I earlier explained when something happened, React create the new DOM from scratch. Then it's check with the existing old DOM and identify the differences. And then identify this part is updated. So then it's going to consider about the subsequent element because the parent pass is already updated. So it means something happened. So then it calls to the browser DOM. This has been please update the particular node and subsequent children as it is. It passed the entire part. Okay, then I move to the next slide. Diffing algorithm. For this purpose, when it comes to the compute diff, and we call it diffing algorithm. And I'm going to explain about how it works. Diffing algorithm is here. React use the traversing mechanism, that is the depth first mechanism. So everybody has heard about the depth first and the breadth first. Depth first is find the leftmost branch and leftmost, then go to the deep, the most deepest point, and check the differences and come to the parent step by step. That is the way. But breadth first is different. Breadth first is go to the first level. Okay, here. First of all, I will explain again with the difference. Let's consider this is the structure, T structure data set. When you come to the depth first is go to the 4A and check the data. Then it's come to the 3, and then it's come to the 2A. Then again come to the 4 and 3 likewise. So, but breadth first is different. It's go to the layer by layer. This means step by. So one, this consider, and this is because this is the second layer, and then it's the third layer. Third layer is the orange color items. Then go to the fourth layer. This is how breadth first works. So then I will explain how it works with the breadth first work with the React. Here let's consider 2A and 4A has been updated. State has been changed. It means the particular node has been updated. Then React check. First do the one, check the one, that's the root element. Then it comes to the second layer. Second layer, you identify something happened in this first item in the left second layer, and to second layer, the other one doesn't have change. So it means then check that one. Then if it identify this one, 2A has been updated, then the React doesn't go through the rest of the items. When you come to this part, I think you guys can see black colored one, 3, 4 and 4. These are the items. It doesn't come to this end, and because it's already identified that 2A has been updated.
Yeah, and I think the reason for that is right, because anyway the React is anyway going to propagate all these elements under 2A, irrespective of the rest of the thing has been changed or not. So I think then there's no point of checking beyond 2A, because anyway you're going to update the rest of the elements also along with it, right? So
yes, correct.
Right? Okay, so then it makes things even faster, right? Because you have to keep on checking each individual elements, right? So given that the root element is already been changed, it's not going to worry about the children underneath, because anyway it's going to entire set is going to get updated, right?
Yes. So when we come to the generic JavaScript application, we have to say 2A has been updated, 4 has been updated, and we have to mention one by one. So then it goes to the depth first level and do the mechanism. So here when it comes to React level, it identifies this one and it identifies the subsequent element and say, hey, browser, this is the should be updated and these are the items. So at once they send to the all one.
But only thing Didula there is like, won't there be any chance like repainting everything if that is the case?
Sorry?
Isn't there a chance that repainting everything, if that is the case? For example, like 2A and 4A is updated, is the traditional JavaScript way, it's going to update 2A and 4A, right? So instead now, in this case, you're going to update everything.
Yeah.
So which means that you are repainting everything.
Yes. Generally, when general application, when it's come to the general application level, most of the time only the bottom layer is updated almost. The topmost is very rarely updated. And other one is the biggest problem with the real DOM, and the real DOM is traversing problem, identifying the particular items. So when we add the two items, let's assume for 2A and 4A, first of all we have to go through the 2A and then again go through from the bottom, from top root element to the bottom again. So we have
identification now. Okay, I get that. So identification is the most like time consuming process, which is not the case here, right?
Yeah, real DOM is optimized for the rendering part, but virtual DOM is optimized for the identification.
Identification. Yeah.
That is the major part.
Okay.
So, okay. So now I'm going to the diffing algorithm. So how it affect to the performance level? When we come to the generic tree structured dataset, it has a complexity. And in order of the big O notation n and 3, we has the n number of the element, and React uses the big O n algorithm. I think everybody heard about the big O notation when considering the data algorithm, and we have identified when everybody has about the worst case scenario, and when you consider the worst case scenario, what would be the complexity calculation mechanism. In the generic tree structure level, it has a huge complexity. This is a big O n 3. Here is the calculation part, n multiplied by n and n again. So let's assume in the today's application, we are developing the single page application and huge application. So it has a lot of DOMs and lot of elements, and when we consider that moment, the complexity will be when the actual rendering level, the actual performance level, it affects the huge level. This is in 1000 level. It's 1000 multiplied 1000 and again multiplied 1000. But when you come to the React, it has a separate mechanism to handle that one, and it's called big O n. It's worst case scenario is the n, then the n is the complexity. So n is the n number of items to be traversed. That is the performance, how it works. Performance has been updated. So when you come to when you check the numerical values, then you can understand how the difference between the actual one and the virtual one. That is the thing, and that is the part of application. What is the part of the virtual DOM, how it works. In additionally, when you understand it, please understand the concept of this, because this is very helpful to understanding how to follow the best practices. So one thing is, when let's assume sometime when property change, it creates the entire new element, entire new DOM. But if the style is updated, it doesn't generate the entire DOM. It just only particular element. So that is the DOM has DOM. Only some elements doesn't care about that one. Styling, some attribute, HTML attribute, data attribute. When we apply that one, it doesn't re-render the entire one. Instead of applying the particular CSS. Recreate the new, instead of recreating the new DOM, it just apply the particular one only. That also I want to explain about that one. That was my today's presentation. Do you guys have any questions?
Didula,
Yes.
Didula, what will happen if we add any element into the tree or remove it?
As you means adding one, adding means when we add into new one, it added to this new element. Okay, how to show this one? Okay, let's assume in this diagram, right one, the green color 2 is there is no items, orange color one. When we apply, okay. Now let's see, I will explain from the beginning. This is the DOM without these orange color items. When two elements are updated, then the React creates the new DOM and React virtual DOM.
Yes.
And then check the existing virtual DOM. Existing old DOM. We call it, we call it a snapshot. Then we go to from the root element and base first. When you compare in the both one, 2 is okay, but when it comes to the 3 layer, it identifies 3 has now new element has been done.
Oh, right. So, that means it will happen in both sides, and that means if it's added, then it will add. If it's removed, then it will remove whole thing, right?
Yes. Almost it is similar to the generic DOM. Only state change and then when change happen, then it might have a big differences.
Right. Okay.
Anything, and if you learning about the React virtual DOM, I kindly mention diffing algorithm is one of the major part, and the breadth first is the one of the major part how it affect. So sometimes when you are considering the performance level, how it affect, so it doesn't. Then when you are study this one, you will get better understanding the breadth first and the diffing algorithm. Okay. Unfortunately, I forgot to add the thanks and the thanks slide. I hope. Thank you everybody. Any other one thing? Next slide. Next one, I will going to explain about the React, and if you need about the, I will try to add some additional how the React DOM. When you're following the best practice, what are the major consideration about the following that one? I will explain that one in the next presentation.
Thank you, Didula. So appreciate your initiative. Hope everyone understood and found this session interesting. So the next Tech Talk session will be on the 18th of September. It's a QA session by Nirmala Katupatage. The flyer will be circulated soon. So highly appreciate your participation. Thank you everyone for taking part. Have a nice day.
Okay. Thank you everybody.
Thank you, Didula.
Thank you, Didula.
Thanks.
Thank you, Didula.